All right. So we're going to talk about classes. So I'm going to create a file. And how can I create a file on the command line? First off, I guess before I do that, how do I know that I'm in the right directory?
I can answer that from yesterday. Type in ls and see
Okay.
what you get.
Okay, so I don't have anything here. So that could be good if I just created like an empty folder. If I want to know, exactly where I am.
Is that a ls-la? Or
Yes, ls will show me everything that's in my current directory. But if I want to see where I am in my computer,
PWD.
okay, so PWD will give me a path to where I am in my, starting from whatever user I am. You can go farther back than this, but so it'll tell me like basically exactly where I am in the computer. So users, code platoon, desktop, code platoon, Python classes, and I can ls as Cindy said to see everything that's in my current directory, and I can do ls-a to see everything including hidden files. In this case, there's just the dot and the single dot and the two dots. And what is the single dot?
that hidden
Current
file?
directory?
Yeah, so it's a hidden file, yes, and it's also a reference to the current directory. And the two dots is a reference to the one directory up. All right, so now I know where I am and I know what's around me, so I'm sure that I'm in the correct file. So now I want to create a file.
So you touch and then the name of the file .py.
Okay, so we'll do so we're gonna make a book class. So yesterday we saw an example of a book class. We started with we're imagining ourselves as designing this application for a bookstore, if those things even exist anymore. So you have a bookstore, you're selling books, you need to be able to represent a book. So one thing you can do is just create kind of from scratch every single book object that you need. And you can use a Python dictionary to do that. So, so we can have a title, two key value pairs or as many key value pairs as you want, a title, and then an author or an ISBN or the price, anything else you could think of. But if you do that, you'll find that you end up repeating yourself a lot because every book is going to have a title and it's going to have an author and so on. So rather than starting from scratch every time and repeating yourself, we can write a class. So can someone who doesn't have prior experience with classes tell me what a class is?
A
Jeff,
template?
Oh, okay. Okay, great. So a template, yes. So that is a good answer. So a template. So it's kind of like an abstract representation of what, in our case, any given book should have. All of the properties that a given book should have, without specifying what the actual property is. So all books should have titles, but we don't know what the title of a particular book is yet. Excuse me. So if we want to create kind of a book, an abstract representation of a book, like a book template or a book form, then we can use a class. We can do that in Python, class, and the convention is capital. So book, and then a colon, So we could just do something like, I think this will work. So pass is kind of like our dummy, don't throw an error thing. So we have this class book, which really doesn't do anything at all. So we have classes, and then what do we use classes to do? So we have an abstract book or a book template.
You create instances of the class that, like if there are fields under there, they have them filled in.
Yes, exactly. So we have the class here, but what we actually want to end up making, our real goal is to create a bunch of instances of this book class. So we can create B1 equals book, and the syntax is just like calling a function. And then we can do B2. Now, are B1 and B2 the same thing?
No,
No?
they're just going to use whatever instructions we put in the class.
Okay. So let's just see, let's take a look at B1 first. Print B1. So if I just call print on this, whoops. If I just call print on this, Python's going to give me this thing. Now we can actually, well, we won't talk about it now, but we can actually override this default representation. That's one of the things about classes in Python, is that it's all customizable. And since everything is basically derived from a class, we can do that. But here's the default representation. So you get the memory address, and we know that it's a book object. So it's something, it's an instance. You can think of object as meaning basically instance. So this is an instance created from this book class. And here's where it lives in our memory. And if I want to see all of the properties that it has, I can call dir on it. I can see all of the stuff that it has. Notice that it's getting this stuff for free. Like I didn't give it these properties, right? So it's just inheriting all of these properties automatically, which is why something like, so if I do print and I'll just give it a list. What do you think I'm going to see? What are some things that I'm going to see if I run this file?
You should be able to see all the methods that you would be able to run on any list, for example.
Exactly. So things like copy, count, extend, index, insert, pop, remove, reverse, sort. So all kinds of stuff that are methods. And then we also have this whole collection of these kind of special double underscore, or sometimes called magic methods, which we usually don't call directly. But we can override them. We can override what they do. So this LE, for example, this is less than. So if you use the less than operator under the hood, this is the function that will get called. Okay. So things inherit all kinds of other properties. So our the instance that we create of this class also gets some stuff for free just from Python. So let's try comparing these two. So B1 equals B2. And that is false. So even though at a certain, in a certain sense, they're the same, right? They're both just instances of this class, and they don't have any special properties. They all have the same. They have the same properties and everything else, but they are distinct objects, and they have distinct memory addresses. So I can. Here's another introspection thing. So I can get. If I call ID, I can get the memory address. Oops. And again, you'll never like really need to use this for anything, but it's a way to check and see if what you're dealing with are two different things, basically. So these are two different things. They live in two different places. Okay. So we have our class book, and we have two instances, but our book isn't really doing anything. So one of the methods that we get is this init. So dunder init. And while we very rarely will want to override these dunder methods, when you create a class, you almost always want to override this particular dunder method. So the dunder init method will be run when you create. There's actually a couple methods that will get run, but essentially, a slight oversimplification is that this init method will get run when you create an instance, right? So if I create an instance of book, then book's dunder init method will run. And when that method runs, then it's basically like you can put things in there that are supposed to be unique to a given instance. So for our book class, the things that we want to be unique for a given instance would be things like title and author. So in this case, we will override the init. I'm gonna and again, this is a bit weird. We can talk about it a little bit more today, but you need to pass sorry, you need to pass a reference to the given instance in these functions. So that sounds weird, and I'll show you an example of what that might look like in a second. But so the first parameter of any function that you have in a class is going to be self. Now this is not determined by the language itself, but it's a very, very strong convention. So I could call this whatever I want, but every other Python developer in the world uses self to do this. And self is like this in JavaScript. Okay, so we have self, and then we have title and author. And when we actually, so what this init method is doing is saying, when I create an instance, I want to pass it these two values, so that the given instance that I create has a title and an author. In order to do that here, what I need to do is say self.title equals title. And by the way, these don't have to be the same name, so I could call this book title. Self.book author equals author. And again, we see this self showing up. And this self is going to be a reference to the instance. So in this first case where we create an instance and we assign it to this B1, then self is going to be B1. So it'll be B1's book title and B1's book author, right? Not just it's not the whole, it doesn't belong to the book as such, it belongs to B1. And B2 will have its own book title and book author, right? And B2 and B2 and B1 won't know what each other's title and author is. But they will both have a title and an author. So just like when I fill out my tax form, which I still haven't done yet, that doesn't mean I know anything about anyone else's tax form, except for the fact that, you know, I know that the tax form asks for a name and a social security number and stuff like that. All right. So now I create this book, but I've basically changed the signature. I've changed what's required to create an instance of a class. So now I need to pass in a title and an author. So I think we did title is, let's do hop on pop, and author. Okay, so now when I create an instance of book, I say, okay, I'm going to create an instance of book, and I'm going to give you 2 parameters, and you know, under the hood, this method is going to be run, and whatever we pass in here as a title and an author will be assigned to B1's book underscore title property and B1's book underscore author property. So now we can actually check if those exist. So print B1 dot book title, for example. We get hop on pop. Are there any questions about this so far?
Just to clarify, it just by nature of it being a class, it just skips over that first self parameter and goes straight to the title and matches that with the first incoming argument.
Right. So so Python will include this parameter automatically. It does it under the hood, but you still have to specify it. So if I don't specify it, Python will supply, well, this won't work for a couple reasons, but it'll try and supply a self argument and it won't work. So we'll see this. We'll write another method later on where we can see this. It's a little clear what's happening. But for now, just at least for the first couple days, every method that you write in a class should have self as the first parameter. There are exceptions to this that we'll look at later, but the 90% of the time you're going to include self here, and we'll talk about those other cases later. Okay, so great. So we have this class, and now we can just start churning out instances of books. So we can create a whole bunch of books. So that's great, but these books only have properties. But oftentimes we want things to have both properties and actions, or properties and methods. So we can actually give our book some capabilities. So we don't really think of a book as doing things necessarily, but we can give it like a method that will access a property. So this is a common pattern. It's called a getter. So things often have getters and setters. So a getter is something that accesses a property, something like the book title or the author. And a setter is something that can create it or change it. So we'll write a method that will enable us to to get a book title. So we'll do get title. And again, this is a method in a class. So by default, you should be including self. And we really don't need anything else because we just want to get the title. So we don't need to pass it a parameter. And we'll return, I'll just return an F string. All right. So, so now my book class doesn't just have properties, it also has a method. So I can call this method. So I've created an instance of B1. So now B1 has these properties and it also has this method. So I can call B1's get title method. So how do I call B1's get title method?
Is it going to be get title B1?
So like this,
So like call a function with that parameter. That's what I was aiming at.
okay. So where am I? So I have
So
a
you're
class. Am I inside this class right now?
No.
Okay. Yeah. So I'm outside this class, and this is a method inside this class. So this is basically, I mean, this is a separate namespace. So I can't just grab get title. And
So you
use
have to
the
start with def again?
so you use the def keyword when you're creating the function. When you're trying to call a method or a function, you don't use def.
You just use the B1.getTitle with no parameter.
Yeah. So can you tell me what you're thinking is there?
You're calling the function of the class. So B1 get title will just naturally pull whatever B1's title is.
Yeah. So we create an instance of the book class called B1, which means that B1 has a book title, B1 has a book author, and B1 has a get title method. So we access B1's stuff, B1's methods, by calling B1 dot whatever we want. Just like when we have an array and we want to call the pop method on the array, it's array dot pop. It's the same thing. Or array.
Is it considered like a good practice to not call the variables directly, but to have methods to call them like this? Or
yeah, so Python is not really restrictive. So there are other languages, most other object-oriented languages, lower level languages where you have things called private variables. So you would probably want to set these as private variables, and then you use a getter to access that. So you can't. I don't know if it's worth necessarily going into that, because you can conventionally mark this in Python by using an underscore in front of the property name. But this is just a convention for other developers. It's not enforced. You can also use a double underscore, and Python will mangle the name a little bit, but you can still access it. But despite the fact that there are no real private properties, that the convention from other object-oriented languages is sometimes still followed.
So now if we run dir parentheses B1, we get title included in.
Yeah, great question. So let's try doing it.
Would we also get book title and book author in that too?
Anyone want to place any bets?
I think we will.
Okay.
I think we will because you can access it with the dot.
Okay. Let's see. So we have at the end book author, book title, and get title. So we have these things that we added, and then we have a whole bunch of stuff that Python added for us.
I'd be willing to bet that with a standard dictionary, that adding like stuff to the dictionary, those things won't be added to the dir.
So if we if we did something like this, and then started putting stuff in this dictionary.
The stuff would show up, but not the stuff inside of stuff. And
Right.
and I meant like outside of the class, if you made a dictionary, and then you did ran a dir on that dictionary, that the
Okay.
things inside the dictionary that we added wouldn't show up.
So if we run dir just on a dictionary, then we get all of. So again, this is like the stuff that Python's doing under the hood. Here's the stuff that you can access as dictionary methods: clear, copy from keys, and so on. So we're not, when we create a class, we're not doing anything else. We're not doing anything to anything else. So Python objects aren't affected by what we're doing here. If I'm not sure I completely understood your question.
I'm not worried about it.
Okay, sorry. But yes, okay, so we can see all the properties that we added to this book class. Okay, so let's go back to here, our method. Right, so I'll have to print this. And we get the expected output. And we get the expected output. So a couple kind of weird things. One is that we have to create an instance. Well, let's see another way of doing this. So there's another way of doing this, and this is not what you would do. You can do it this way, and this is kind of more what Python is actually doing. But you start with book, so the class, we do get title, and we pass in B1. So I think this is kind of what Anthony may have been getting at earlier. So is this going to work?
Will that give you all the books in that directory and not in the directory, but in B1? Will that list all the books if you had more than just hop on pop?
So yeah, so that's a good question. So this class book, as it is now, won't know anything about instances that are created from it. So if we create 1 million book instances, book itself won't necessarily know about them. I mean, the way we have it written right here. Does that make sense?
Yeah, but I'd say now B1 equals book, which would be hop on pop. So that's why I would just do the one. It wouldn't do, if you had a million titles, it wouldn't, it's not linked to the other titles, correct?
Yeah, so if we had another instance of a book, then we could pass in B2 to see B2's title. But this part would stay the same. So
Makes sense.
let me run this. And we get the same result. So don't do it this way, but this is why we have this self parameter. This is what Python is kind of doing under the hood. This is why you have to include self as the first parameter. Okay, so when we want to use an instance method, an instances method, we first off create an instance, and then we just call the instances method, whatever dot whatever. Okay. So let's say we want to let's add another method. So let's do get author. So we'll pass in self just because we always do. And then I'm just going to return basically the same thing. All right, so now I've added another another method. I'm going to add a third method. And this method is going to be something like get all information. And I'll pass in self as the first parameter. All of these are just all of these only have self as a parameter, but I can, if this were a method, I can add as many other parameters as I want, just like a normal function. So if I want to get all info, I could copy both of these lines and paste them, but what I'd like to do is call get title and get author. So how might I do that?
Self.getTitle and self.getAuthor.
Okay. Can you tell me why you think that will work?
Because self represents where you're at within the class itself. So it by default would basically say you're inside of class, so self dot, and then if you list the function names, it kind of knows where those are.
Okay, yeah, so self will refer to the given instance of a class. So this is kind of just a placeholder for right now, because our class doesn't know anything about the particular instances that will get created. But once I actually create an instance and I call that instances get all info, it will have access to self because it will be that self. And self.getTitle, i.e. b1.getTitle and b1.getAuthor will exist. So that's how you call those methods, right? We call getTitle by calling b1.getTitle. So we'll do that here, but we don't have a specific instance yet. So we have to refer to it generically. And we do that with self. So return self.getTitle. We'll just do, I'm not going to format this, self.getAuthor. All right, so let's try printing this out. So how would I call, let's see, yeah, how would I call this B1's get all info?
B1 dot get all info.
Okay. B1 dot get all info. So this is not formatted, but it's fine. So the title is Hop on Pop, and the author is Dr. Seuss. So we have an instance, and we call that instance's method, this get all info method. And that instance also has access to every other instance method and property, right? It has access to book title, book author, and then these methods, get title and get author. So you refer to those within the class by self. So self is like the generic stand-in for whatever specific instance that you end up creating. Are there any questions about that? Okay. Well, why don't we take a 5-minute break, and then we'll come back and we'll look at the solution for palindromes. All right, so before I get started on the palindrome challenge, does anyone want to tell me what test-driven development is?
Process of thinking about what you want to pass, writing your test so you could test it, and then going back and doing your code so it passed that test, and then just cycling through it.
Yep. Yeah, exactly. So the the kind of shorthand form is red, green, refactor. So red means you write a test that describes some small bit of functionality that your code should be able to do. You write the test, and then you run the test, and then that test should fail because you haven't written the code yet. So that's red. And then once you have that test, you write the minimum amount of code required to pass that test. Then you run the test again, and then when it passes, it's green. Refactor is just, look through everything, make sure it still makes sense. You don't want to change anything. And then, yeah, keep repeating the process over and over and over again. So for every small change you make to your code, you have a test that covers that change. And in the end, you have one documentation. So your tests serve as documentation for what your code does. And two, you have this source of stability. So if in the future you make changes to your code, you can, if your changes break anything, then you know that you've done something wrong. Okay. So I'm going to share my screen. And by popular demand, we'll do palindromes. So I'm going to fork the repo. This is PD Bravo Platoon's palindromes. So I'll fork it so that my GitHub repo will have its own copy. Okay, so now I have my my own copy of palindromes, and I'm going to go in here, copy this so I can clone it down to my local machine. Do ls, make sure that I'm in the right directory here. I can look around. I see that I'm in desktop/coplatoon, which is why we have this, right? So we can tell where we are. And I'll do git clone. And now I have palindromes, and I'm going to do it in Python. So can I just start? So what happens if I try to do is this going to work?
On a basic level, you got to move into the Python folder.
Yeah. So I'm telling Python, hey, run this palindrome spec file. And I'm implicitly telling it that it's in the current directory. So if I do ls and I see what's in the current directory is palindrome underscore spec.py in this current directory. No, it is not. So I could give a fuller file path, a relative file path. So I could do something like Python palindromes and then Python and then palindrome .spec. So I could run that. Is this going to work?
Sure. I mean, it's going to
Probably.
work, but it's not going to work because the function's not written yet. But it's
Right. Okay.
going to run it.
Yeah. So I'm not going to get an error because it's the wrong file. Indentation error. Okay. So you don't necessarily have to be in the directory where you're running the file is, but it's probably a good idea just for the sake of consistency. So I'm going to go into palindromes. I'm going to do ls. I can see that I'm now in a Git repository because I can see that I'm on the master branch. I can cd into Python, and I'm going to check out what's in the palindrome spec. So palindrome, so it looks like I have a bunch of things. So palindromes, capital letters, and then the more advanced stuff is like spaces and periods and other stuff. So I can look at the tests and kind of see what I'm supposed to do, but I'm actually not going to use this directly. I'm going to write my own test file just so we can do this piecemeal. So we have this palindrome function, and I'm just gonna get rid of this. And before we start writing, let's think about what we're actually trying to do here. So we need to check if a word is a palindrome. So I'm sorry, I have a cold and a young son who doesn't sleep very much. So the strategy, the kind of obvious strategy would be you want to check and see, want to somehow get the string word as input, then reverse it, and then see if it's the same as the original string. Something like that. So that's a basic strategy we're going to follow. It's kind of the most obvious. So we'll kind of just see if we can describe this out a little bit more. So we will make a copy of the word, the original word, and then we will somehow like reverse that word, a copy, and then we will compare. So something like this. So I think that will work. So one thing to note in Python, you can use, if you want to make comments, you can do this. If you want to do extended comments, you can do triple quotes, either single or double. Then you can write stuff, and it's fine. So this is good for doc strings, sometimes in a class or in a function. All right, so let's fill this out. Let's add some more steps to see if we can fill this out a little bit. So the first thing we have to do is make a copy of the original word. So let's write this, make a copy of the original word. And then the next thing we have to do, so we can see from our tests that we're going to have to handle some things like capital letters and spaces and punctuation. So I don't know exactly how we're going to do that, but let's say we're going to have to somehow clean, we're going to have to clean whatever we get. We have to clean the input. So regularize or clean or whatever. So I'm going to do clean the copy, and I guess I can include this in the same. So clean the original. So we're gonna have to clean both of them so that when we compare them in the end, we'll have undergone the same processing. Okay. So the next would be reverse the cleaned copy. So
Would it be simpler to clean the original word and then make a copy of it?
I don't know if that would necessarily make a difference. So you'd still end up with the original, then you have to process it, then you have to compare it. So it's just a matter of, I guess, what order you do. I'm not sure if there would be an advantage either way. If anyone else has any thoughts, feel free. Okay, so then we're going to compare this reverse clean copy. So the reverse cleaned copy to the cleaned original. So I get given a word, let's just say ABC. I clean the copy. I make a copy, so now I have two ABCs. I clean both of them, so they're all lowercase and there's only A through Z. Then I reverse the clean copy, so CBA, and then I compare CBA to ABC. In that case, they're not the same, so ABC is not a palindrome. So I think that's probably fine as a starting point. So what I'm going to do now is I'm not going to write just one method. One, because when you just write one function, because when you just write one function, it's harder to test. You can certainly do that, and that's fine. But testing is a lot easier when you break things up. So I'm going to start with making functions for all of these things. So I'm going to use a, I guess, what is sometimes a convention, and I'm going to create a main definition. So I'm going to do def main, and this is kind of going to be the entry point, and it's basically going to be the runner. It's going to kind of be in charge of the order that everything happens in. And main is going to get whatever the original word is. I'm going to start with that, and then I'm going to look at what I have to do. So I have to make a copy of the original word. So I'm going to add a function that does that thing. Again, you're free to organize things how you like, but one philosophy says that functions should do just one thing. So def make copy, and that will also take a word, and then we'll do word copy equals word, and return word copy. Oh, actually, okay, I should be writing this right now. Pass. Okay, so I have my make copy, and then what I'm going to do is clean. So I'll have a clean function, def clean. Clean, so it looks like it'll take a word still of some kind. And then I think the last thing I want to do is compare the reverse. So I'm going to compare two words. So def, I'll do, I'm going to end up comparing the reversed cleaned. So reversed clean copy with the cleaned original. All right, so I think this is probably enough to get started. We may end up changing things around, but I think this will be good for now. So now I'm going to create a test file. And the first thing I'm going to have to do is import this palindrome.py. So I'm going to import all of these different functions. So I'm going to do from palindrome import main, all the other ones, make copy clean, compare. So now I can use all of these functions here. So first thing I'll do is I'll test main. So print so one kind of first thing to do with any function is just test the type of the return value. So type equals. So ultimately, I think what we want to return is a Boolean. So we want to say if it's, ultimately we want to see if it is or is not the palindrome. So we'll return a Boolean. So let's go ahead and run our test. And false, so that fails. So we have our first failing test now. So we have to go back here and let's make this pass. So this needs to return a Boolean. So we can just do that. True. Then run our test again. And now it passes. Okay, so let's do the same thing for make copy and clean. Whoops. And make copy. So we're getting string as input initially, and we're making a copy of it, so it should be the same thing. So it should also be a string. So str. So let's run that. And it's false. So make a copy. I'm going to add a little bit more than the minimum just to move things on a little bit, but as I had before, word copy is word, and then return word copy. I can do something like that, and then if I run this, it passes. So I'm giving it a string, and it returns a string. All right, so let's move on to clean. And what is clean going to do? So clean it's going to take a word, because we have to run this for both the copy and the original. So it's going to take in a string and it's going to do some stuff, and it should also return a string. So let's make sure that it returns a string. So that is false. So for now, I'll just do this. This will be a little bit more complicated. And the test passed. So lastly, we'll do compare. And it's going to take two things. And compare should return a Boolean value. So if the two things are the same, it'll return true. If they're not, it'll return false. So let's do Boolean, and we'll run this, and the test fails. So red, green refactor. Let's make it green. Compare, and then return. We can just go ahead and write it out. Basically, reverse equals cleaned original. We'll run the test again, and now we're passing. Okay, so we still got some more work to do, but I think we have a good baseline for what we're doing here. So I think the first thing to think about, so compare is written, make copy is written, clean might take a little bit of work. So the first thing we need to do is, well, I guess we need to do two things here with clean. One, we need to regularize punctuation. So we can basically make everything lowercase. We can also make everything uppercase, but we'll make everything lowercase. And then the second thing is we need to remove anything that's not A through Z or like a letter. So what I'm going to do is I'm going to break those up into two different functions. So I'm going to add another function. So lowercase, pass, and then I'm going to do def. Remove bad characters. This will also take a word. So I just added two functions. So I'm going to have to go back into my tests file, and then I'm going to add these in the import statement. So I'll do what do they call them? Lowercase and remove bad chars. All right, so lowercase. Is this stuff pretty thrilling?
I was on the edge of my seat.
What's going to happen next? Is he going to check the type again? Who knows? So I don't want to spoil the surprise, but I am going to check the type again. So lowercase. It's going to take a word, and it's going to return also it's going to return a string. So it's going to take a string and return a string. All right, so we'll run this. It fails. We'll go back here. And I'm just going to write this out because it's very easy to do. So return word dot lower. This is a built-in Python method. So that should be, that passes. Okay, it's easy enough. Now we're going to do remove bad characters. And this one will also be a string. So that's false. So red, green refactor, run red, and so this, we'll have to figure out how to do this. So for now, I'll just give it a dummy value. Okay, so now all my tests are passing again. So let's think about this clean. So this clean method is going to end up, I think it should end up calling both lowercase and remove bad characters. So I will call lowercase is lowercase. And then I'm going to call, I'll just call this fully cleaned will be remove bad characters. And I'll call that with the lowercase.
Jay, what's that mean to remove bad characters? Is that taking away apostrophes, numbers, things like that?
Yeah. So all of the like spaces, the period, the dashes, the comma, the stuff we're getting here. Okay, so clean is going to call both of these. So let's figure out what we're going to do with remove bad characters. Now there are a number of ways to do this, but I think the simplest way would be to use regular expressions. We haven't explicitly talked about regular expressions, but Python has a number of different things. So we'll have to import the Python regular expression module from the standard library. So Python, you can think of Python as kind of having 3 layers to it. There's the core language stuff, which is, you know, things like for loops and if statements and objects or dictionaries and functions and all of the basic stuff you can just use ordinarily. But then there's also an outer layer of stuff called the standard library, which is usually more specific, has a more specific application. It's still part of Python, but you have to import it explicitly in order to use it. You don't have to download anything. It's not a third-party module. It's still a part of Python, but it's part of what's called the standard library. So, and the regular expression module is called RE. So I'll import that here, RE. And then what I'll do here is, so RE has a bunch of stuff on it. And one of those methods is sub. So what we kind of, in plain English, what we want to do is we want to get rid of all this stuff. But just going through and deleting stuff is, there may not be a method that's directly designed to do that. So what we need to do is replace whatever we don't like with nothing. So we're going to use this substitution, and this happens to take 3 parameters. Again, this is something you would figure out by looking things up, right? This is not something that I just know automatically off the top of my head. So put this little R here. So now this will all be taken. This will all be taken literally, and excuse me. So this W, again, this is just regular expressions. You can look this stuff up. You don't need to memorize it. But a capital W means anything that isn't like an ordinary character. Things like periods and spaces and all that stuff. So I want to find anything that isn't a normal character, and I want to replace it with nothing, an empty string. And I want to perform this operation on word. And this method will return the modified word. So it should still be a string. So if I run my tests, it should still all be passing because this should still be returning a string. So I guess I was bad here. Let me go back. I went out of order. So let's write a test that has to fail first. So we'll go to remove bad characters and we'll do remove bad characters. And we'll do something like so we should get that right. So we want to remove all the stuff that isn't normal letter, and that's what we should get. So let's check if this works. Nope, we get a failure. So we go back, we figure out how to make it not fail. And let's run this again. And now it passes. And of course, ideally we'd be writing more tests. This is just kind of like the bare bones, so we're not here for 2 hours. Okay. So remove bad characters. So let's also check our clean now. So we want clean, when we call clean with a word, we want it to remove both, or we want it to basically be all lowercase and only letters. So let's write that test for clean. So print clean, we'll do a, yeah, whatever, that's fine. So exclamation A, that should equal lowercase a. So we'll run this test. Yes, that fails. So this is one reason why you want to use a testing library, because this is very quickly going to get hard to read. But in any case, we have a failing test. So now let's make sure that it passes, and we'll return fully cleaned. So that should do the trick. And we get all trues. So that passed. Okay. So I think we've now, obviously, again, all of these should have more tests, but skipping the for the sake of time. So we have all these methods. Can anyone tell me anything before we finish up with main? Can anyone tell me anything about these methods? We talked about this concept, I think last week. Purity and impurity.
I think they're all pure because they don't write anything into the console.
Yeah. So, sorry, can you say again why they're pure?
Because they're not writing anything to the console. They're returning items instead of writing to the console.
Yes. So one way that a function could be impure is if it writes something to standard output, like the console. There are a few other ways it could be impure as well. It could change global state. So if I had some variable somewhere outside of this function, and then I called make copy, and make copy did something like this, then make copy would no longer be a pure function because it does stuff that's not, there's not complete referential transparency. So it does stuff, and depending on what this value is, this will end up creating a different value, right? So what's happening here is dependent on things outside of itself. So that's one form of impurity. So functions should only, they should be restricted to themselves. So a function should only do stuff that's within itself. It shouldn't change anything outside of itself. It shouldn't be changing things outside of itself includes writing to the console or making making a network request or anything like that. So it takes in things and see, this makes a copy of the original and then returns the copy. So that's another thing that pure functions do. When they get input, they don't modify it in place. They will, basically make a copy of it or something like that and return a new version of the thing. So pure functions, this is kind of an ideal from functional programming, which is competitive, a competitor to object-oriented programming, although we will use both of them. You don't have to just choose one or the other. But one of the benefits, and there are, it's more than one, but one of the benefits of functional programming is that it makes unit testing much, much easier. So because all of these functions are pure, they're very easy to test. I just give it an input, and every time I give it that input, it will always return me the same output every single time. It won't change anything else. I don't have to worry about any other variables in my application. It's very, very consistent. And that's also one reason why I broke up something that could have been written as one function into lots of other functions, so that every single little bit of logic can be tested. Okay, so let's work on main here. So main here is going to be like the runner. So it's going to start with, it's going to get a word, and it's going to need to run the correct functions in order, and then ultimately return a Boolean. So the first thing, again, I'm not sure. I mean, there might be a couple different orders that I don't know if one is necessarily superior, but if you happen to know that one way is better, please let me know. But first, we'll make a copy. So equals make copy. Okay, so we have a copy, and then what we need to do is we need to clean both the copy and we also need to clean the original. I guess let me start again by writing a failing test. So let's call main. So A, B, C, something. Okay. So clean original, so clean copy. Actually, this will take word. We're gonna clean the copy. We're also gonna clean the original one. Okay, and then once we have both of those, then we're gonna need to compare the two. So we can call that is palindrome. Compare. We'll do. Oh, we forgot reverse. You guys didn't even mention that. It's like the most important part. Reverse. All right. So let's write that. How could you guys let that slide?
We were testing you. That's right. We were testing you.
Or you're gonna do some kind of cool trick at the end, and like,
I don't know any tricks that cool, unfortunately.
I don't know if it's gonna bite you yet, but go back to that make a copy thing.
Uh-huh.
Python Python passes pointer references. So you basically created a new variable called word copy and it's pointed at the exact same address. So that's not technically a copy. I don't know if it's going to bite you yet. I guess we're going to find out. I feel like you should I feel like you should leave it for now and see if something weird happens.
Yeah. So it will. So it's because it's a string, it's immutable, it's a primitive value. It actually will create two separate things, but it's a little weird in Python. I was actually playing around with this earlier, and if you copy the memory address, they'll both have the same memory address until you change one of them.
Yeah.
So it's like it's like it is lazy. So it's almost like as if originally, like at first it'll just be a reference, but then if you actually change it, it will evaluate or fix itself. So it's a little weird. I'm not entirely sure what Python is doing under the hood or why it's doing that, but
yeah, it does the same thing with like integers too. So if the moment you do like a string concatenation, the concatenated two strings returns a brand new string with a new memory address. But yeah, I haven't seen I haven't looked at the rest of everything going on. So if you are just doing like a concatenation later, it's gonna be fine. It's immutable, so it's not gonna. It really depends on what's happening. I'm just curious. I'm curious to see what's gonna happen. So
yeah, it gets tricky with lists.
Yeah, so lists are definitely going to be references. So you can't just if you do this with a list, then it won't work because you're still going to be dealing with this. You just have two different names for the same list.
Yeah, you would have to do like copy.deep copy.
Yeah. Yeah, so there's a couple ways you can copy arrays in Python and deep copy. Yeah. It's the same thing with dictionaries as well. So it's a gotcha. It's definitely a gotcha, something to think about and pay attention to. And this happens in both JavaScript and Python. Okay, so the reverse order. So reverse order is going to take in a string, yeah, and it will also return the reverse string. So I'll do pass. And so I write my test for the import. What did I call it? Reverse order. Finally getting some suspense here. I like it. All right, so we'll run this and it fails. And so we do, I'm gonna skip ahead a little bit. So, or we would just return a string and then we would write some other stuff, but again, for the sake of time, so return. And what I'm gonna do is, there's a few ways we could handle this. I like list comprehensions in Python. We haven't talked about those yet, but they're very cool. So list comprehensions, it's a way of kind of generating a list. So the syntax is weird, kind of looks like a for loop, but it's a bit strange. So car for char in word. And then this will give me an array of characters in the word. And then to reverse it, and there's more than one way to do this, I will just do this. So this is something that's unique to Python as well. So you can slice strings. This, which is empty, this is like the start, stop. So these are both empty. So this means the whole thing, start at the beginning, which is the default, end at the end, which is the default. And then this is the step. So just like the range function has a start, stop, and step, this has a start, stop, and step. And in this case, the -1 means start at the end and go backwards. So now we created an array of characters in the word, and then we reverse that. And then I'm going to join that into a string. So we run that, that is true. So that's returning a string. And again, I should write more tests to make sure that that's actually working. But I'm going to, let's use our magic and we'll just say that we run all those tests. So yeah, so once I clean the copy, I clean the original. Also gonna want to reverse the original. Reverse. Is that what that was? Reverse, it's called reverse order. Okay, cool. Okay, so let's just walk through to refresh myself. So we're gonna make a copy. We're going to clean the original. So remove uppercase or change uppercase to lowercase and remove punctuation and so on. Then we're going to do the same for the copy, but we're also going to reverse that copy. And then when we finally compare, we're going to pair the reversed cleaned copy, and we're going to compare that to reverse.
Now, Chad, are there going to be issues because you've got two lines, the cleaned and the reversed are both underlined? Is there an issue or something missing, or why is that?
Give me 1 second. Let me type out reverse clean copy, and then this will be cleaned original. Okay, sorry. What was the question?
Never mind, I spoke too soon. I was asking about the underline. Well, now it's
Yeah.
under just
Yeah.
palindrome.
So that's good. So there are we'll talk about linters a little later, but this is like a code spell checker kind of. So they're different. This is kind of just a warning. So a yellow means it will still work, but it's telling me that I have an unused variable. So unused variable. So I've created a variable, but I'm not using it, so it's pointless right now. I will use it in a sec, but right now my linter is telling me that, hey, you're not using this variable. All right. So again, I didn't do this in order. So this equals false. So let's try doing a simple one. ABA true. So it looks like that's working. So, so this works. Again, we could write lots more tests here to be testing more thoroughly everything that's happening, to be testing edge cases and so on. And then, of course, ideally in here, we would be doing error checking and things like that. But just as a basic exercise in test-driven development. So it's, it's a lengthy process, but I think in the end, you get code that ends up being more reliable than you would ordinarily have. Are there any questions? Okay, so I'm going to go ahead and push this up. All right, get status. Okay. Yeah, I'm going to add a get ignore so I don't push up the pi cache. Can someone tell me what the git ignore does?
So it doesn't upload those files to GitHub.
Yep. Yeah. So these PyCache files, these are generated when Python compiles the code, so it doesn't have to keep recompiling every time. But you know, those aren't useful to anyone, so you generally don't want to push those up. So git okay. So I'll do git add. I'll add everything. Git status. Looks like everything's good to go. And then I'll do git commit. And then git push origin master. I think maybe next week we'll start doing branches, but for now that's fine. You can just stay on master. Push origin master. We go up here. I'll refresh. Again, I'm in my forked copy here of palindromes, and I have a recent commit 20 seconds ago, right? So this stuff is new. So then what I do is I make a pull request. Go here, pull request, new pull request, create pull request. So I'm going to push. I'm telling, hey, PT Bravo Platoon palindromes, I want you to use my code. We're not actually doing that, of course. You're not actually going to merge, but that's how we run this. And create pull request, and then that's it. So now if you look here in the pull request, you should see my solution right there.